Good afternoon, everyone. Welcome to physics tutorial. So the last time we had a video, we're talking about current electricity, and we looked about resistors in series, resistors in parallel, and we also saw how Ohm's law was working in a simple circuit. All right. So in continuation with current electricity, today we're going to look at or a brief introduction of simple AC circuit. So AC simply means alternating currents. The previous video was about direct current circuits where we use batteries. But here we use an alternating current system whereby the voltage and the current are in phase and in some cases out of phase. So it's called the sinusoidal method. Now, in looking at alternating current, we are going to look at specifically current, we are going to look at specifically voltage. Now, in these two cases, there's current, right? And there is what? There is voltage. Now, what makes a sinusoidal system or what makes a current to be in phase and out of phase? First of all, alternating currents are represented in form of a graph whereby the movement is sinusoidal. So that means we have peak points and we have minimum points. Okay. So this can be either V or I and against T. So first of all, let's start with current. So the simple waveform for a current in alternating form is given as thus: sine 2 pi f 2 pi f 2 pi f t. Now let's define each of these variables. I is called instantaneous current. I'm going to explain what it means. While I naught is peak 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 current, while WFT W pi f is called angular velocity, and of course T is called time. Now how do we explain this now? Now, instantaneous current is the current delivered per time at a particular moment. So it's called instantaneous current, while I naught is called the peak current. So in this case now, in every graph form, the maximum point is called amplitude. Yes, amplitude or maximum displacement. So that is where we have our I naught. That's where we also have our V naught. I'm using one graph to represent two relationships. So this is where our peak current is. This is where our peak voltage is. While this W means angular velocity. So we can write this again as I naught sine WT, where W is angular velocity. So the distance from here to here, it is angular velocity then with respect to time. So when you look at this, we can do the same thing for V. Instantaneous voltage is equal to V naught sine W2. So this is how simple AC circuits work. Now, under simple AC circuits, we have three components we are going to look at: the resistance. We are going to look at capacitance. We're also going to look at what we call inductance. Now, capacitance and inductance, they are all opposition, but we classify them as one. Now, look at Ohm's law. Ohm's law says V is equal to IR. So this guy here is the opposition to this current. Okay? So, in a capacitive circuit, that means in a circuit that has only capacitor, we don't have a resistor, we don't have an inductor. The opposition is the capacitor. The same thing with the inductance. So in another circuit, so you could have V is equal to IC. This is our opposition. You could also have V equal to IL. This is our opposition. So, but totally, an electric meter only measures resistive load. It does not measure capacitive or inductive load. So we are going to look up into all of these things and derive each of their formulas, and then also give examples of instances where we have a capacitive circuit, an inductive circuit, and in some cases, we have all the three components in one circuit. So I think I'm going to stop here. In the next video, I want to do more. Thank you for listening.